Well, now we're going to do grade 11 and exponent and surds, addition, subtraction, multiplication, divisions of powers with numerical basis. And then the second question says simplify the following. Let's start with question A. I'll write the question over here. Let's say A is 10 to the x multiplied by 25 to the x plus 1 all over 5 to the x multiplied by 50 to the x minus 1. Now the idea here is to, we're going first to write the numbers that we have here in terms of the prime factors, okay? You know, 10, if you split it in the as product of prime factor, it's gonna be, let's write like this, multiplied by that, x plus 1, all over 5 to the x multiplied by test with x minus 1. So 10 can be written as 2 times 5, okay, in terms of its prime factors, okay, product of prime factors. 2 and 5 are prime numbers. So 10 can be written as 2 times 5. 25 is like 5 to the power of 2. And then 5 is already a prime number at the denominator here, so I'll leave it like that. And then 50 will be like 2 times 5 squared. If you're unsure how to do that, you can use the factor tree. Okay, I'll do 1 for 50 here. Like by 2, it's 25. By 5 is 5. And then by 5 is 5. It's 1. And then this is 2 times 5 times 5. This is equal to 2 times 5 to the power of 2. Or you may also use a calculator. Over here, you can just write 50 in the calculator, 50, and then press equal. And then you press the shift button here. And then press the button that we see here called effect. On top here, they say effect. And then hit the effect, you have 2 times 5 squared. Okay. Now we can simplify this. How can we? Remember the law of exponents says that if you have like a times b to the power of x to the power of n, okay, this is equal to a to the m multiplied by a to the n, okay? So this is the same law we're going to apply here. It's going to be like 2 to the x multiplied by 5 to the x, okay? Multiplied by 5 to the 2. Over here, we need to be very careful when we do, when we times this exponent, we don't say 2x plus 1, actually it's going to be 2x plus 2, because that's why I will advise to write 2 open brackets x plus 1, like that. Over, okay, 5 to the x multiplied by 5 to the x multiplied by 2 to the power of x minus 1 multiplied by 5 to the power of 2 open bracket x minus 1. So this will be then, once we reduce the numbers in terms of the prime factors, we can just write, look at how many bases, different bases we have here. Only 2, we have 2 and 5, okay? So I can just write 1, 2, and then I am going to add to combine all the exponents. Like here, the exponent is x at the numerator, so I write x there. And then is there any 2 at the numerator? I don't see any, so that's all. Then I will subtract this exponent here by the exponents of the exponents that have base 2 at the denominator, okay? Like here, for instance, it's x minus 1, so I'll say minus open bracket x minus 1, because I will subtract this with the whole thing here, okay? Then I'll do again, multiply by, I write 1, 5, then I do the exponents here, okay? Okay, let's start with this one. It has x there. I'll say x. First we did 2x, and then that one, 2 to the x and 2 to the x minus 1. Now we are going to select all those that have 5. Okay, we have this one, that one, that one, and that one. So there are 4 of them. So I start by putting x here, and then minus over here, we do 2x times x, and then 2x times 1. Not because it is at the numerator, it's going to be a plus. So plus 2x plus 2. Now this one is at the denominator. Okay, so we do minus x. Okay, and then minus the product here is 2x minus 2x, and then 2 times -1 makes -2, and then minus that also becomes plus 2. I don't know if you get it. Okay, let me write it this way, maybe. I first combine those at the numerator, okay? Then I will minus by the one at the denominator, so minus x, this x here, and then plus 2x, excuse me, 2x minus 2, okay? So this is x is there, plus 2x plus 1, I expand this, minus by the exponent at the denominator, so x here, minus, open bracket x, plus 2x minus 2. Now, let's continue. This will be equal to 2, that makes x minus x plus 1, multiply by 5, and then x plus 2x plus 2 minus x minus 2x plus 2. Okay, we can simplify. That makes x and x here 4, so just 2 to the power of 1, which is 2. Okay, multiply by 5. Okay, and then let's simplify. There also we have x and negative x, simplify 2x and negative 2x simplified, and then positive 2 plus 2 makes 4. That makes 2 times 5 to the power of 4. And then 5 to the power of 4 is equivalent to 625, and this is equal to 625 times 2 is equal to 1,250. Okay, that was question A. Now we're going to do question B. Do it over here. B is given by 6n plus 2 multiplied by 10 to the power of n minus 2 all over 4n times 15n minus 2. Okay, watch carefully what we do here. We're going to first step 1 is to write all the numbers in terms of the prime factors. Okay, the prime factors of 6 is just 3 and 2, or 2 and 3. So I can just say this to the power of n plus 2 multiplied by, okay, 10 is like n to the power of n minus 2 all over 4 also in terms of its prime factor to the power of n times 15 also to the power of n minus 2. Now let's split 6 in terms of its prime factor. It's 2 times 3. 10 is 2 times 5. And then 4 is 2 squared. And then 15 is 3 times 5. Now we're going to apply this law of exponents. You know, the power here will be apply for all the numbers within the bracket, for everything within the bracket. So this will be 2 to the n plus 2, okay, multiply by 3 to the n plus 2, multiply by 2 again to the n minus 2, multiply by 5 to the n minus 2, all over, that makes 2 to the 2n, multiply by 3 to the n minus 2, multiply by 5 to the n minus 2. Now that I reduce all the numbers, okay, in terms of the prime factor, we can just write 1, 2 here, okay? And then I start, look here, how many do we have here? We have this one, and that one. So we can combine these, okay? The exponents here will be, we're gonna do n plus 2. This is at the numerator. So I'll plus it with the other at the numerator. So plus n minus 2. Is there any other to the numerator we done? Now I'm going to minus with the one at the denominator. So minus 2n. Done with the 2. Then the next base is 3. So we have 3 there, 3 to the n plus 2 there, and then 3 to the n minus 2. So I'll just do multiply. I'll just multiply here by 1, 3 there, and then the power will be n plus 2. Okay, that's the numerator. No more. Now I will subtract with those at the denominator. Open bracket, n minus 2. Please use bracket to avoid unnecessary mistakes here. Okay, then we will then consider the other term. So the other number, so we have like this and then that. So I'm gonna write multiply by 5, okay, to the n minus 2. Okay, this at the numerator, and then minus n minus 2 at the denominator. Now let's continue. Now simplify. So this will be equal to 2. So here we have like n plus n minus 2n. They all simplify because it's 0. And then 2 minus 2 also simplify. Okay, all these simplify because that makes 0. So this is 2 to the power of 0. Now multiply by 3. Now over here, this is like n plus 2 minus n plus 2. Okay, and then you see that n minus n also simplified, and then multiply by 5 to the power of what? That makes n minus 2 minus n, and then plus 2. And now you notice also that n minus n falls, and negative 2 plus 2 also falls, 0. So here the answer will be like 2 to the power of 0. All this makes all of this just 0. Okay, so 2 to the power of 0 is 1. 5 to the power of 0 is also 1. So we have like 1 multiplied by 3 to the 3 squared, multiplied by 5 to the power of 1. And then this is just 3 squared times 1 times 3 squared is 9, and 9 times 5 will be 45. So the answer is just 45 here. Okay. Let's see. The other question is question C. The question says 6 to the x multiplied by 9 to the x plus 1 multiplied by 2 all over 4 to the n multiply over 27 to the x plus 1 multiplied by 2 to the x minus 1. Now we do the same thing. We're going to reduce each number here by its prime factors. Okay. You see that 6 is same as 2 times 3. Okay, and then 9 is like 3 squared, and then 27 is like 3 to the power 3. Okay, so we can do we can now reduce split these. That makes like 2 to the x multiplied by 3 to the x multiplied by 3 to the, over here it's going to be 2 open bracket x plus 1. Okay, multiplied by 2. 2 is like, there is an invisible power of 1 there, and then all over 3 to the power of 3 open bracket x plus 1 multiplied by 2 to the x minus 1. Now that we write each term in terms of its prime factor, now that we have all the prime numbers here, basically that's what I wanted to say. Now that we have like prime number, the bases are all prime numbers, we can just write 1, 2 here, okay? And then we said, if I look at the terms that end, I mean, the basis of 2, they are there, and also there. You can just say, okay, 2 to the power of x, okay, plus 1, okay, minus, you want to add the denominator, use brackets, so x minus 1, okay, close brackets. Now, I'm gonna do now 3, the base 3. The base 3 are here, here, and here. So this will be, I'll write 3 there, and then it's gonna be like x plus, because at the this is at the numerator, I'll say plus 2. Okay, we can 2, that makes like 2x plus 2, okay, and then minus, at the denominator, it's gonna be open bracket, that makes like 3x plus 3, okay, minus 1 at the denominator. And that's all. So now let's continue. That makes like 2 to the x plus 1 minus x plus 1, okay, if one had drop brackets here, and then multiply by 3 to the x plus 2x plus 2 minus 3x minus 3, okay, and then this will be, then we can simplify x and negative x there, simplify, and then 1 plus 1 makes 2, okay, and then over here you have like x plus 2x and negative 3x, they simplify, and then 2 and negative 3 makes negative 1, so over here it will be like 2 to the power of 1, I mean 2 to the power of 2, multiply by 2 minus 3 is 3 to the negative 1, so this is just 2 squared over 3 to the negative 1 is just, sorry about that, it's just, we can write it like this, we can move it at the denominator, because you remember this law of exponent that says a to the negative m equal to 1 over a to the m, and then this will be equal to 4 over 3, okay? Well, the next question is question D here, okay? Let's just move, start with question D. Question D here says 8 to the power of n multiplied by 6 to the power of n minus 3 multiplied by 9 to the 1 minus n all over 16, my fraction line, all over 16 to the n minus 1 multiplied by 3 to the negative n, okay? So first of all, we are going to write each numbers in terms of the prime factors, okay? So 8 can be, I'll say here 8 to the power of n multiplied by 6 to the power of n minus 3 multiplied by 9 to the power of 1 minus n all over 16 to the power of n minus 1 times 3 to the negative n. Now I'm going to write 8 in terms of its prime factor is 2 to the power of 3, okay? And then 6 in terms of its prime factor is just 2 times 3, and then 9 is like 3 squared, and then 16 is 2 to the power of 4. Now, that we did write in terms of the prime factor, we can simplify. That makes 2 to the power of 3n, okay? Multiplied by 2 to the power of n minus 3, multiplied by 3 to the n minus 3, multiplied by 3 to the 2 open bracket 1 minus n, use bracket here, okay, all over 2 to the power of 4, open bracket, n minus 1, times 3 to the negative n. Now that we simplified, we can just write numbers like, let's see, in this group, basis of the number that have basis 2 are this one, we have this one, sorry, I meant this, and that one. Those two have basis of 2, so I can write 2 to the power of 3n plus, okay, n minus 3. And now we're going to minus this with the denominator, which is 4n minus 4, okay? Because, you know, over here we times 4 times n and then 4 times negative 1. Then we're going to do times. I'm going to write 3, and then the basis of 3 are this one, that one, and that one. So we can just write here n minus 3, okay, plus over there it's going to be 2n minus, no, not 2n, but 2 minus 2n. We do 2 times 1, and then 2 times negative n, 2 minus 2n, and then minus minus negative n, okay, minus use brackets, minus negative n, okay. So over here we can just write 2 to the power of 3n plus n makes 4n, 4n minus 3 minus 4n plus 4, okay. When we drop the brackets, it comes like that, times 3 to the power of when you see here n minus 2n makes just negative n, and then negative 3 plus 2 makes negative 1, minus n makes a positive n, okay. We can simplify again. So 4n and negative 4n falls, and then negative 3 plus 4 is just 1. So over here, the answer is just 2 to the power of 1 multiplied by the negative n and positive n falls. And then we have like times 3 to the power of negative 1. So which is just 2 over 3. Okay. That was question D. We can also do a question E. Question E says 2 to the x plus 2 minus 2 to the x plus 3 all over 2 to the x plus 1 minus 2 to the x plus 2. Okay. So in this case, this case is a bit different because we have separated terms at the numerator and the denominators. Okay, this is a term, this is a term, this is a term, this is a term. So we can solve this by factorization. I'll look here at the numerator. I'll look here which one has a smaller exponent. Okay. First, we identify the smallest exponent is over here, 2 to the x plus 1. Now I prefer to take it as a common factor. Okay. I'll write here 2 to the x plus 1 for the common factor. Okay. Let's move it like this. I'll take this for the common factor. Now, over also, I'll take there also 2 to the x plus 1 for the common factor. Now, if I take 2 to the x plus 1 to the common factor, remember that 2 to the x plus 2 is, this one is the same as to say 2 to the x plus 1 plus 1. Remember? Okay. Or we can say I was saying it's like 2 to the x plus 1 plus 1, which is the same as okay, let me move gonna show this is, I was saying this is like 2 to the x plus 1 plus 1, which makes plus 2. Now it can be reduced as 2 to the x plus 1 times 2 to the 1. Okay, same also as here. This is 2 to the x plus 1 plus 2 can be written as 2 to the x plus 1 times 2. Okay, so in the brackets here, it's going to be like 2 to the power of 1, okay, which is just 2, and then there it's going to be like minus, okay, I mean 2 to the power of 2, sorry, okay, because the exponent is like 2 to the x plus 1 plus 2 to the power of 2, yes, minus 4, that's 4, okay. And the denominator, if I take 2 to the x plus 1 out for the common factor, understand that it has like a 1, invisible 1, it's these times by invisible 1. So I cannot put 0 in the bracket, but just write 1 minus 2, because 2 to the x plus 2 is just like 2 to the x plus 1 times 2. So I can write it like this. Then we can simplify this and that. And then we have left with what? 2 minus 4 is negative 2. And then 1 minus 2 is negative 1. And then the answer is just 2. Okay. We can do also F here. Question F says 9 to the x plus 3 to the 2x plus 1 over 18 to the x multiplied by 2 to the 1 minus x. Okay, so first of all, I'm going to write 9 in terms of its prime factor, and 18 also in terms of prime factor. 3 and 2 are already prime numbers. So this will be to the power of x plus 3 to the 2x plus 1 all over 18 to the power of x multiplied by 2 to the 1 minus x. Now 9 in terms of its prime factor is 3 squared, and 18 in terms of its prime factor is 2 times 2 squared. Okay, so this will be equal to 3 to the 2x, okay, plus 3 to the 2x times 3 to the 1, okay, all over that's going to be like 2 to the x multiplied by 3 to the 2x multiplied by 2 to the 1 minus x. Okay, so over here, at the denominator I can combine them, because notice that we do have like same bases. The base here is 2 and the base there is also 2. So we can combine the numerator, the base of the numerator, of the denominator, I mean. So this is going to be like 2 squared. And the numerator cannot, because I have a plus there. At the numerator, what I can do, I can take 3 to the power of 2x for the common factor. Note that the product is, there's an invisible 1 there. So I can take 3 to the 2x for the common factor. And then this will be, I left with 1 plus 3, okay? All over at the denominator, it is also 3 to the 2x times 2 to the, there I can just say x plus 1 minus x, okay? Because they're both at the denominator, we can combine the exponent, add the exponents. Now, there we can cross this and that. And then here also x and minus x falls. So the answer would be like 1 plus 3 is 4. 4 over 2 to the power of 1 just 2. And then this answer is 2. Okay. We can also, the same way we can do question G. Question G is 3 times 2 to the x minus 2 to the x minus 1 all over 2 2 to the x plus 2 to the x plus 2. Okay, so in this case, we can write 3 times 2 to the x minus 3 is already a prime number. I don't need to reduce anything there. So it's going to be like 2 to the x times 2 to the negative 1 all over 2 to the x plus 2 to the x times 2 to the 2. So we can take at the numerator here, we can take 2 to the x for the common factor. So this is going to be like, if I take 2 to the x, sorry, not 2x, but 2 to the x for the common factor, it will be, are left with 3 minus 2 to the power of 1 is the same thing as a half, okay? All over, at the denominator also, I can do the same, I'll take 2 to the x there, understand that there is a 1 times that, so it's going to be like, if I take 2 to the x for the common factor, it's going to be 1 plus 2 squared, which is 4. And then we can simplify x, 2 to the x and 2 to the x. And then 3 minus a half is 5 over 2. This is equal to 5 over 2 all over 5. You know, when we have a fraction of another fraction, okay, the main fraction line is this one. And then over 5 is like, there is a denominator of 1 there. So when we have a fraction of another fraction, what we do, we will multiply the first fraction by the inverse of the other fraction. Okay, so there we can simplify across like that. And then the answer here is just a half. Okay, that was G. Now we can also do H. Let's see. H is here, and then we do I. H says 4 to the x plus 2 to the 2x minus 1 all over 2 to the 2x minus 1. Okay, then 4 to the x can be written as in terms of its prime factor, okay, plus 2 to the 2x minus 1 can be written as 2 to the 2x times 2 to the negative 1 all over 2 to the 2x times 2 to the negative 1. Now there we can write it as 2 squared, okay, in terms of its prime factor. And then this will be like 2 to the 2x plus 2 to the 2x multiplied by 2 to the negative 1 all over 2 to the 2x multiplied by 2 to the negative 1. Then we can take 2 to the 2x for the common factor. That's going to be like, remember that there's a 1 times that. So there it's going to be like 1 plus a half, because that's 2 to the negative 1 all over 2 to the 2x times a half. Then we can simplify this and that. And then 1 plus a half is like 3 over 2. And then a half is there. And then this will be like 3 over 2 multiplied by 2 over 1. Okay. And then we can simplify that, and then the answer is just 3. The answer is just 3. Okay. And we can also do question I. Sorry. I, which was 2 times 3 to the power x plus 2 plus 3 to the power of x minus 3 all over 5 times 3 to the x minus 2. Then we can also do 2 times 3 to the x times 3 squared plus 3 to the x times 3 to the negative 3 all over 5 times 3 to the x times 3 to the negative 2. Okay. Now we can check 3 to the x for the common factor, 3 to the x for the common factor, and then this will be 2 times 3 squared is 18. Okay, if I do this 2 times 3 squared is 18, minus 3 to the negative 3 is like 1 over 3 cubed. Okay, maybe because of space, let me write it this way. We take 3 to the x for the common factor, and then 2 times 3 squared, we said it's 18, minus 3 to the negative 3 is just 1 over 3 to the power 3 over there also we have like 3 to the x times 5 over 3 squared. Okay, and then we can simplify 3 to the x and 3 to the x, and then that makes 18 minus, that makes 18 minus 1 over 27 all over 5 over 9. Okay, we can use a calculator for that. Let's just do it. 18 minus 1 over 27 up this way. 18 minus 1 over 27 all over 5 over 9. Okay, and that's 97 over 3 over 3. Yes. So thank you.